Hello, everyone. Welcome to 24 Hours of Past, 20 Years of Past Learnings and Future Visions. We're excited you could join us today for Kevin Kline and Richard Douglas session, Baselining and Alerting for Microsoft SQL Server. This 24 Hours of Past consists of 24 consecutive live webinars delivered by expert speakers from the Past community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when these are available. If you require technical assistance, please type your request into the question pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session, which will pop up after the webinar ends in your web browser. Your feedback is really important to us for future events, so please take a moment to complete this. I'd like to take a moment to thank our sponsors, Microsoft and Intel. The staging of 24 Hours of Past wouldn't be possible without their generous support, and they are the reason this event is all available free of charge. If you would like to learn more about Microsoft or Intel and sign up for information on how they can help you, please visit the sponsor page of the 24 Hours of Past website. Keep learning all year long with Past. Visit past.org and check out all of the free educational resources available to Past members. Also, don't forget that Past Summit 2019 will be happening on November 5th in Seattle, Washington. Head over to pastsummit.com and register today.
Oops.
No problem. This 24 Hours of Past session is presented by Kevin and Richard. Kevin is a Microsoft SQL Server MVP and a founding board member of PAS. He is also the editor-in-chief of SQLServerpedia.com and the author of popular IT books like SQL in a Nutshell by O'Reilly and Associates. Richard, please switch the slide. Yeah, Richard Douglas.
Oh, yeah, there it is.
Richard specializes in the SQL Server product range at SentryOne. He has worked with SQL Server since version 7 in various developer and DBA roles and holds a number of Microsoft certifications. Richard is a keen member of the SQL Server community. He runs PAS local group in the UK and has served on the organization's committee for SQL Relay. And without further ado, here is Kevin and Richard with baselining and alerting for Microsoft SQL Server.
Thanks very much, Milan. Appreciate it.
No problem. Thank you.
All right, everyone. Well, thank you so much for carving some time out of your day to spend it with Rich and I. We really appreciate it. We know that you've got a lot of other things you could be doing with your time. And so hopefully you'll get a lot of value out of this session and you'll feel like it was time well spent. Rich and I have been in the database business for a long, long time. And we worked together at another company before we came together at SentryOne and had the opportunity to work together building products like Plan Explorer and SQL Sentry and a variety of other products like that. And one of the things we talk a lot about is the different things that really raise the skill level of DBAs. Take it from kind of a base entry level skill of a DBA into higher level skills that you find only with the really serious enterprise level DBAs who work at the highest levels of IT. And one of those things that we agreed is held in common among those top skilled database administrators is the ability to run baseline and benchmark tests. So we're going to spend some time today talking about those. We're going to also spend a lot of time explaining what it takes to pull off a baseline successfully, the preparations, the prerequisites, and the things you do in advance that really ensure a highly successful baseline test. We're going to dive in to the metrics that are needed, that you have to collect during a baseline or a benchmark. And it's more than just metrics. There's a lot of things that you want to keep an eye on as you go through the process. And then also one other takeaway is that we have written a lot about this. So if you want to watch more videos on the topic, we have white papers, we have other resources that'll take you through the whole process in greater detail, step by step. You can see those at centuryone.com/resources. So one of the things that's really interesting about knowing how to performance tune your environment, and baselines are not just about performance tuning. They're actually about much more than just that. But one of the things that we see happen all the time is that when people encounter performance issues, their first impulse is to max out the hardware. You know, if the hardware has a little bit of extra space for memory, or you could put in faster disk drives of some kind, maybe move to SSDs. That's the first impulse. And yet when we look at the research from organizations like Gartner Research and others, what we find is that the performance gains are most strongly noticed, not at the Windows OS, which you can see here is on the, the much lower end of the scale of what gives you performance benefits. A little bit better than tuning Windows and the OS configuration settings is to tune the SQL Server settings. And then hardware is only about 5 to 10% of your performance problems. The remaining 80% is in your database design and in your application code. And so this is the sort of thing that benchmarking and baselining helps reveal to you and helps you identify what is normal versus what's abnormal. You cannot really effectively tell what is abnormal if you don't know what normal is. And that's kind of the heart of baselining and benchmarking. It helps you characterize what is normal under given workloads. So Rich, do you want to dive into that in a little bit more detail?
Sure, yeah, thanks, Kevin. I would just say one thing, seeing as this is being sponsored by Intel, that yes, you should all go and buy some Intel CPUs. That will make things much, much faster. Obviously a nice plug for them.
Yes.
So we are going to be talking about baselines and benchmarks today. I'm going to draw on something that happened to me today, and Kevin and I haven't actually discussed this yet because my flight was massively delayed. And so we're going to be talking about baselines and benchmarks in terms of flights right now. So if we were benchmarking something, we would be looking at the level by which something could be measured or judged, such as top flight speed and things like that, and distance, etc., etc. And then we would know that a plane can run for a certain amount of time, and theoretically it should be able to get to its destination in, that certain period of time. However, there are other things that can cause problems, much like the tuning cycle that Kevin just showed you on that particular graph, that there are different areas in this. We'll be talking about different areas like service and concurrency problems with runways, for example. Now, when it comes to baselining, this would be talking about a measurement or a calculation that can be used for a basis of comparison. So this would be the level of service that you would expect to be provided by a particular company or by a particular application potentially. And that's the way that we should probably be thinking about this moving forward, in that it's a type of service and a guaranteed service level agreement or key performance indicator that we need to be providing to our clients. And those clients can be internal or they can be external, i.e. they provide us with nice money. So what would we need to be doing? So for a baseline, we're trying to take the typical state of a system to understand what's going on. This would also mean that it's not going to be a short period of time, but would typically be an average period. So by an average period, we would mean something like a typical business cycle to get a true understanding of an end-to-end process. We're probably also going to want to look at multiple different types of baselines, because you're going to have different kinds of workloads during different parts of the day. So if we kind of go back to the flight scenario, things like summer holidays where you've got children off school, etc., there's going to be a lot more demand for seats, and so things are going to be a lot busier in the service department than they would typically in maybe a normal February, for example, where it might be a lot quieter. So we're going to want to have different kinds of baselines for different workloads. So as a DBA, that's going to be things like my maintenance windows. We're going to be wanting to have different performances, different performance metrics for things like our seasonal peaks, and so on and so on. So the whole idea of this, as Kevin said before, is to identify what normal means to you. And we're going to be talking about specific metrics a bit later on, but the whole thing is, this is designed to show you a range of metrics that is ideal for you and your environment. So we'll give you some guidelines, but those guidelines will really be based on your hardware, your throughputs, your knowledge of SQL Server, and how much transactions per second you can actually get through from a particular SQL Server application.
Indeed.
So with the benchmark side, we'll be looking to identify bottlenecks because we know the theoretical throughput, and we would do this using TPC tests. So TPC is the Transaction Processing Council, and they've got a number of different kinds of tests that you can use. And there's all kinds of different software that's available for free and for paid versions as well available. And you can use those for things like standard OLTP or OLAP style transactions, and you will then be able to get an understanding of the kind of throughput that you should be seeing, and then you can tune those lower levels that Kevin was mentioning before, things like the hardware, the Windows, the SQL Server side. These are all things we can tune through the benchmarking part.
I tend to think of benchmarks as hypothetical. Like, what if we need to scale this application up to 1,000 current users, and we're currently running at about 400. So a benchmark would be something where you scale up and you're testing a premise, whereas a baseline is much more around measuring what you currently have and giving you that kind of basis for comparison to say, is this normal or not?
Absolutely.
Now, just to add on to that, why go to all this trouble? You know, I had mentioned that this is something that we see happen primarily at the higher ends of the enterprise IT spectrum. And again, it boils down to this idea of, in the long run, you know, Peter Drucker, one of the famous management gurus of the 20th century, said, you cannot manage what you cannot measure. And so, you know, we're database administrators, we're database managers. We want to keep an eye on all of the different important metrics so that we can adjust accordingly. And so using a baseline becomes the bedrock foundation of a service monitoring mentality. What you're going to do is observe and assess the performance of your servers in real time using different monitoring and alerting types of systems. And this is extremely important for a number of reasons. One of the things that I do like to point out is that for a long time, I and many of us have determined whether our systems were doing well or not simply by how much the phone rang. And that's actually not the right way to do things. You know, when people call you as the DBA, they're already upset. So what we want to be able to do is get into a position where we discover the problems before anyone ever calls us. And hopefully we take the opportunity to fix them before anyone ever notices and complains. That actually is a very edifying experience. It lifts us up. It raises our credibility. You know, there's an old joke that the acronym DBA doesn't stand for database administrator. It stands for default blame acceptor. You know, this is the person who always gets blamed for performance problems. So the more we can head off calls and be aware of what the performance of our system is and react and respond accordingly, the stronger our credibility is in the organization. And another thing that's also kind of interesting about this too is that there had been times in my early career before I started to use baselining and before I started to use alerting, and I know Rich can tell some stories of his own about this, where I didn't know about a problem that happened over the weekend when no users were on the system. And so it took 2 days for the users to start complaining, when if I had implemented a baseline and had alerting in place, I would have known far in advance and would have been able to fix it before any users had even gotten onto the system to complain about performance. So by doing this, we get a very, very greatly improved consistency of service. At the end of the day, that's what we want to provide: predictable, stable, and consistent performance. And like Rich said, when you have that consistency and predictability, that helps set expectations in the future. And when you're able to meet people's expectations regularly, that improves your standing in that organization.
So I think my favorite story around alerting happened when I was a production DBA and I was on call. What happened was absolutely nothing. There were no problems, and we got into work the next morning and we faced the wrath of the IT director, who said, everything's gone down, you were supposed to be on call, what happened? And it turns out that the MX Exchange server was also down, so we received no notification about it.
Oh my gosh, that's terrifying.
So single point of failure, yeah, lesson learned.
Lesson learned indeed. So let's talk about the goals of a baseline. It's not just to collect some metrics, is it?
It's not, no. So what we want to do is, as we've said before, to try and understand what normal is. We're trying to understand when we're seeing those exceptions, and then ideally be able to automate some kind of response around that. Now, that's going slightly out of the realms of what we're going to be talking about today, but that should be the end goal of any kind of DBA. What we're trying to do is to mitigate these problems, and if these problems do arise, then come up with some kind of automated fashion to resolve those automatically, or automagically, as I prefer to say. So this really does help us to understand what's going on and informing us about all these things. So the best way that we can do that is to document what's happening as best as we possibly can, because that's going to allow us to understand the kind of applications involved, the levels of drivers inside of the hardware, and all kinds of other things that become really, really important, so we can see potentially what has changed, and then see if there's a way of either changing that back, rolling back that particular change, or seeing if we can roll up something else forward.
And like you said, when you do encounter a problem and you know what the normal performance metrics are, it becomes really easy to compare what is happening right now to, kind of the normal circumstances of and performance metrics of your server, and identify pretty quickly what is unusual. If it shows that your PLE, for example, your page life expectancy of memory, is suddenly extremely short compared to what it normally is, that helps you track down the problems much, much faster. Now, another really neat value add of a baseline, as it shows in the third bullet point here, is that when you collect your baselines, it also helps you identify certain kinds of situations that either require a response. Not all situations do, though, so it also helps you identify whether you have any of these circumstances that might be things that are safe to ignore, and then you can actually build traps, you might call them, alerts that don't tell anyone about what's going on. They simply trap that information so that it doesn't send any false alarms. And I'll give you an example of that from my experience too. Back in the day when we had very large replication environments with dozens and dozens of servers sending data in all kinds of different directions, doing these different baselines, we did not realize immediately that the full extent of what replication does. And so one of the things that happens in replication is, let's say a WAN router, a link between two different offices goes down. Well, replication is designed to be a little bit resilient in those kind of circumstances. And so it doesn't fail the transactions that it sends across, it queues them up so that when the link is restored, it's able to send all those transactions through. And it wasn't until we actually ran our baselines that we were able to determine, oh, you know what? We don't have to have a reaction to these failed transactional replication events because it's going to automatically try to fix those. So that was a situation where we were able to identify some problems that did not need a response. On the other hand, you might find that you get certain kinds of errors on the regular or certain kinds of circumstances that are not ideal. And so you can build in responses to those when you initialize or implement your alerting features. Now, a real common question that we get is, well, I've been a DBA for a long time, and this isn't something that I have been doing in the past. What other things could you tell me about that I need to start doing in order to, be this kind of senior level DBA? And that's one thing that Rich and I do spend a decent amount of time evangelizing. Rich, you want to talk about the maturity model for a few minutes?
Yeah, I absolutely love this. So a lot of us can relate to what's going on here. We're not all lucky enough to kind of join Microsoft straight out of college and things like that. So our typical jobs that we start with are typically going to be level 0 or level 1, which is things are really, really chaotic, or we're in a really reactive phase in terms of the business maturity. So what we're trying to do is we're trying to put in this baselining process. And as you can see through some of these highlighted sections, is that baselining is actually going to help you to go up this step ladder and to help you to become more of a mature business. So we're going to be looking at things like alerts and event management that's highlighted here that we've already spoken about. Analyzing trends is quite key with the baselines because we can see the deltas between the two baselines that we've taken. We're able to set these thresholds. So once we understand the workloads, we can say, here is what our normal looks like. And so our threshold should be between ranges A and B. If it's below those or above those, then we know there's a problem. And people tend to forget that if things go below a threshold, that can also be a problem. If we think about things like transactional throughput, if that suddenly drops massively during the peak part of our day, we would want to know why, because that means potentially something else has gone wrong that maybe isn't being monitored. And that could be a massive problem for us. Maybe not from a database perspective, but maybe it's some kind of load balancer that's gone down in our web tier, and we're not seeing quite as many people. And so if that was somebody like Amazon in their retail environment, that could cost them millions and millions of pounds or dollars or whatever your local currency is. So understanding how to set these thresholds and to alert on these is absolutely key for being able to provide a certain level of performance and a certain level of income for your business. And so that helps us to talk about the guaranteed SLAs as well.
Oh, I'm sorry, go on.
No, go ahead.
Well, I was just going to point out one thing that we notice here is we look at level 0 and level 1. You're just keeping the place alive. You're not really adding any value to the business. As you get to level 2, though, and then even more so at level 3 and level 4, this is where you add value to whatever the organization is trying to accomplish. And I've had a lot of DBAs, Rich, I know you have too, who said, you know what, I never get invited to the strategic planning sessions. And my response to that is, that's because you're over here at level 0 or level 1. You're just fighting fires, you're fixing problems, you're doing backup and recovery frequently. You're not yet able to become proactive and manage things in advance before they actually happen, to foresee things. And so if you take a look at these different levels, especially going up to the right-hand side, that's where you start to become a partner with the business rather than somebody who's just keeping the business afloat.
Absolutely. So I like to say that the sweet spot for a DBA before they kind of turn more into management is probably around the 3.5 mark if we were to look at this, these stepping stones,
Hmm.
where we've gone past the proactive stage, we know exactly what we're doing, we've got more time to start being strategic, we start thinking of IT as a service rather than just being there and being technology for technology's sake, and actually being able to help our customers. Because that's what it's all about at the end of the day. We're helping people to achieve more, whether that's through a product or through a service. That's all that we're trying to do, to do more things for more people.
Hmm. Well, let's talk about performance tuning. There's a lot in the middle of this stack of maturity skills around predicting problems, monitoring end user response time. So certainly you got to do some performance tuning in there. Let's talk about that a little bit.
Yes, so the performance tuning lifecycle really does hinge around the baseline. It's very, very critical to how this would work. So the first part of doing anything, any kind of performance tuning, is that you need to have the end in mind. That means that you need to be defining a goal before you can go any further. Now, this goal is likely to be some kind of arbitrary number, like maybe 1 second or whatever it might be for a query, or you
Hmm.
must be able to perform, 10,000 transactions per second or whatever it might be. Okay, but that goal has to be set. The next stage is to go through and to see where you are right now. Obviously, that goes back to our baselining. We want to understand where we are right now. So we're going to be creating that initial baseline. From that, we should be able to see where potential problems are from the metrics that we've collected. Then we should be hypothesizing how we can change these things to reduce the amount of resources or the amount of weight that we're seeing. So we're then going to develop and test the solution. And then obviously we're going to want to try and see if that works. So we're going to deploy the change. Now you will notice that this says change, not changes, and that's on purpose. We want to make sure that we're only changing one thing at a time. Otherwise, we could hide other performance problems that we've put in here. So if we were making 10 changes and only 8 of these made things better, there are 2 little sneaky things in there which could have made things worse. And we could
Hmm.
actually be reducing our throughput compared to what we could have potentially been achieving. So you're going to want to make that iterative change one thing at a time. And that's where the cycle comes in, because every time we make that change, we then update the baseline with by running whatever process it is, and then identifying the bottlenecks again. And it goes round and round and round until we suddenly jump out of the loop because we understand that we've actually met the goal that we defined at the very beginning.
Hmm. And this is a really good example too of why another skill that DBAs try to cultivate is the ability to automate stuff. Because if you're going to change one thing at a time, it's going to take a while to get this working, to get every variable you want to test tested. And so if you could automate all of that, it'd make it very easy. Well, how about a little metaphor for your idea here?
Oh yes, my famous metaphors. Okay, so DBAs generally love coffee. I know of like 3 people who don't. And so I decided that if I ever retire from being a DBA or being in this technical field, what I'm going to do is I'm going to make up my own coffee company, and I'm going to call it Doug Bucks. And obviously the goal for this is to make the best cup of coffee in the world. So that's my defined goal right there at the top. I need to make the best cup of coffee in the world. So as part of my baseline, obviously what I'm going to need to do is I'm going to need to make a cup of coffee, probably quite a bit more than 1 cup, but you get the idea. We're going to make some coffee. Now, the next stage is going to be going through and identifying the bottlenecks. In this case, this is going to be me drinking coffee and seeing if it is the best cup of coffee in the world. Now, as we said before, some of these things are objective because, it's one of those things. Page life expectancy shouldn't always be 300 or less than 300 for it to be a problem. It really does depend on a number of other factors. So all of these things are objective. But once I've made that decision on what I believe is the problem, I will go through and decide on that change, make that individual change, whether it's changing the kind of beans, the roast, the grind, whatever it might be. I'm then going to have to go through and make another cup of coffee and test that. Then we're going to go round and round and round until I've either made the best cup of coffee in the world, or it's really, really unsafe for me to be operating some kind of kettle with boiling water.
Perfect. Yeah, exactly. It's the kind of thing, test, measure, analyze, and then make those change, retest. And that's how you move forward. So we're going to spend a few minutes talking about measuring and different performance counters. But before you get to that stage, you want to take some time to prepare and assess and analyze. So one of the things to think about is that when you are doing baselines, there are different significant periods that are important. So for example, many database systems include both a reporting system and they include both the OLTP transaction processing system. And so what that means is that when management is pulling reports at the end of the month, at the end of the quarter, or even the end of the year, there's all this additional kind of reporting workload happening on those servers over and above the day-to-day keying of the data into the system. And so that's a peak load. You probably want to measure both of those separately from each other. So that's one idea. Also, your maintenance windows, those are going to be very, very different typically, when you're doing DPCC checks or when you're doing backup and recovery or all those kinds of things, very different. And then finally, seasonal peaks. So one example I like to give, one of our customers is one of the largest of the different floral companies in the United States. And they had jokingly said to us at one time, we're really only busy 2 months out of the year. The other 10 months are not that busy. We're really busy the month before Valentine's Day, and we're really busy the month before Mother's Day. And you need to know the difference when you do your baselines. Also, patching. It's not uncommon for a Windows or a SQL Server patch to introduce a regression. It's not certainly anything we look for, but it's something we have to be wary of. And so, again, with friends of ours who are customers of SentryOne, some of the really, really big financial firms around the world, they don't roll out any patches without sending them through a testing phase in which they compare the baseline of the before and the after of the patch. And then only after they know that it's in good condition do they roll out those changes. The main thing to be aware of course, is that if you do roll out a patch or a change, and then you have to later roll it back, it's that roll back that is excruciatingly difficult. So this prevents that terrible situation happening, which you have to roll back on a patch. It's really, really hard. And then finally, after failovers or DR scenarios, Rich, you had mentioned to me one scenario in which there was multiple secondaries, but none of the secondaries were as powerful as the primary.
Yes, so I've seen all kinds of problems with this where people have had, we'll now call them always-on clusters rather than just the typical Windows clusters. And what they did is they decided that they're always going to have a preferred node, and so they were going to allocate more memory, more CPUs, those kind of things to the preferred node. It even had SSDs local for tempDB and things like that. And then, of course, when it failed over, the secondary box had, or the other node had half the amount of RAM, had a similar amount of cores, but weren't as fast. And then suddenly people are wondering why things are slower. Yeah, there's going to be a really good reason for that.
Right.
But they hadn't thought about the kind of throughput they would be expecting on that DR server, and we're still expecting to be able to meet certain kinds of SLAs. And so this is where you can go back to the financial department and say, if this is business critical and we are supposed to be being able to provide this certain level, we can't do that on that level of hardware. And that kind of comes back to some of the benchmarking as well, because you would have been able to have tested the maximum amount of throughput that you would be able to get on that. And then you would raise that as a risk as any kind of DR playbook, really.
Yeah, exactly. And you mentioned a very important three-letter acronym there. And if you go back to the maturity model, you see that SLAs are pretty high on the maturity model. What I have found in my experience is that it's not uncommon to see DBAs asked to sign an SLA, but what is uncommon is that they don't really know what it means, right? So I signed an SLA that I'll get the server back up within an hour or 2 hours. They had no input into that, into the SLA, and in fact, there's no way they can meet that SLA. But by doing a baseline, you would know whether you could or not. All right, well, let's dive in a little bit more. We'll need to move along. We've got about 30 minutes left, not quite 30 minutes. What do we need to capture? So there's quite a lot of information out there, and the first thing, as with all of the other steps along, is you got to know what you've got to be able to compare against what might potentially come down the line. So we need to spend time building a very nice kind of documentation around everything related to the system itself, the OS, the Windows OS PerfMon counters, the SQL Server PerfMon counters, and quite a few of the DMVs may also be valuable to you. So things like, what are your wait statistics? What do those look like under normal circumstances? So this is the sort of stuff that we need to collect. Now, the last three of those boxes there are the sort of things you would collect with some queries, perhaps with PerfMon, and that sort of thing. But the first one, system configuration, that takes a little bit of work on your part.
Yeah, so this can be really, really difficult in some ways, especially when you're looking at things like the architecture diagrams, because this is where you want to understand which other components, hardware components potentially, are integrating with your SQL servers. So what kind of tier system is it? What kind of cluster do you have? All these kinds of areas. What's the I/O infrastructure like? How does that work? What's the technical throughput of those? And we need to have that kind of information to be able to see where we should be. And also, if we were to change something, what it was like prior to that change and post that change. So if we are seeing performance problems, then we can potentially roll those issues back. And that comes back to typically the whole patching thing. We've had problems before where a new I/O controller has been released, and that didn't necessarily do what it was supposed to do and caused all kinds of problems. And so we had to roll that back. But I mean, it was such a drastic change in that case that we were able to catch it quite easily. But if it was a minor change, would you spot that in a typical day when you've got lots of other things to do? If you're on that level 0 or level 1 of the tree, probably not. It's only going to be until you've got lots of these small things that have crept up and caused a huge problem together that you'll really notice what's going on. And at that point, it will be so difficult to troubleshoot all of these minor points that you'll be looking at calling in some very, very expensive people to sort the problems out.
Exactly. One of the things I will point out is that one of the things that's great about our community, the SQL Server community, is that we are a sharing community. And so take a look at a couple resources. One is written by Microsoft. It's called the MAP Toolkit. MAP means the Microsoft Assessment and Planning Toolkit. And it can tell you all of the kind of configuration and hardware layout and things like that for a given SQL Server, the Windows box that SQL Server is running on. Now, it only knows what Windows knows. So if you have Windows running inside of a hypervisor, whether that's VMware or Hyper-V, it thinks that's its world. So Map Toolkit will tell you all about what it knows it has at that level. Another great toolkit that's free is called SQL Power Doc, not DOCS. That's actually a very, very different product from a great company out there called Redgate. You want a PowerShell script library written by Kendall Van Dyke. He's a PFE for Microsoft. SQL Power Doc, and it's what it does is it looks at all of these things that we have listed here on this list, except for the architecture diagram. It can't really do that, but drivers, the hardware, Windows and SQL Server information, and it collects all of that for you using PowerShell. And it can also do that for many servers at one time. So you could tell it, I want you to do all of the servers on this subnet, even if they don't have SQL Server. and it will collect that information as well for you. So there are some shortcuts as well as some paid products out in the marketplace that can help you as well. So let's talk about, that's what you should capture. You need to know all of that before you start, but then there are the different counters, the different performance metrics you got to catch. And so we've got all kinds of different SQL Server and related metrics of different sorts. So let's talk about these a little bit. We've got a list here, and you can read these as we go along, and a couple recommended values in here. Let's talk about these for a second.
Yeah, I was going to say there's probably lots of people shouting about the PLE being 300. That's a big disclaimer that that's a well-known kind of internet joke. That figure was given out quite some time ago, probably SQL Server 2000 times.
Yes, exactly.
Hardware moved on quite a bit since then, but people will still use that value because it's still floating around on the internet. So it's there as an inside joke rather than being the true thing. It is really going to depend on the workload that you typically see. So you want to be monitoring things like the page life expectancy, which is the amount of time in seconds that your data is staying on average inside the buffer pool. So the lower that number is, generally it indicates memory pressure, but that will depend on the kind of workload that you're putting through it. If you're doing an OLAP system, I'd expect it to drop down massively when we're doing builds and things. That would be a false positive because that's expected behavior. And so we need to have these caveats when we're creating our alerts around windows of time and things like that based on known workload. And so, as we said at the beginning, these are all recommendations rather than being the gospel truth. Because all of this comes down to understanding the workload in your environment, and when you're seeing deviations from the norm, that's when you should start to be worried.
Right. Another thought too is that there are specific PerfMon counters that you want to capture related to your VM as well as your OS, right? So for your virtual machines, you're going to want to keep an eye on the memory limit reservations, whether there's any ballooning or swapping, CPU ready time. If you haven't heard of that, CPU ready is kind of the inverse of what we normally are used to when we look at CPU counters, which tell us how busy it is. CPU ready is the inverse, how much the CPU is not being used at a given time. So it's maybe if it's 30% busy, then it would be 70% ready. So these are very specific and very useful for VMs. You want to keep track of these as well. And just moving along a little bit further here, we also want to keep an eye on different processor metrics, things related to the amount of CPU used specifically. So you want to capture the overall processor time, yes, but you also want to know how much SQL Server is of the total processor time. So we have a call out for that as the second bullet point here. And if you happen to be running SQL Server and say analysis services or integration services or any of the other things in the Microsoft stack, also capture those as well. Now we do have some general recommendations around these. For example, you typically would want your processor percent time and SQL Server processor time to be less than 80%. Processor queue length is an interesting one. If there is a queue at all for the processor, that means there are threads that are waiting. And that's a very, very good indicator that you have limitations on your CPU. So less than 12 is good, but ideally you're going to have a processor queue length no more than 4. It's going to be less than 4. If it's longer than 4, then that means you've got threads stacked up waiting for access to the CPU. Context switches, also another indicator of memory pressure or processor pressure, I should say, not memory, processor. So again, we've given you some recommendations here. Compilations and recompilations tend to be more important on the older versions of SQL Server. In the very newest 2 versions of SQL Server, they have introduced adaptive query processing, a new feature, and it helps mitigate the danger of recompiles per second. But if you have an older SQL Server system and you take a look at the compiles per second, in proportion to the read compiles per second. You don't want that recompiles to be a high proportion. So keep track of those things. How about I/O, Rich?
Yeah, so I/O is one of those really, really tricky ones because we've got lots of different kinds of I/O infrastructure now, and a lot of the time these are hidden to the DBA because of virtualization and various other things where maybe we've got lots of spindles, but they're blocks against spindles rather than having a dedicated LUN as we would have typically seen in directly attached storage.
Mm-hmm.
So things like disk queue length can be very misleading these days, and I would always refer people back to their own vendor documentation, because some SAN vendors like to have really large disk queues, and they can do some really clever things with cache and hybrid arrays and all kinds of cool things. And so it is very much a case of it depends. You will really need to go back to your I/O vendor to understand what's going on there. Then we've got the different kinds of disks that can provide massively different levels of performance. So the old adage by the CAT team was less than 20 milliseconds for your read performance was good. Less than 10 milliseconds for your write performance was good. And it's interesting that write performance is a lot more important than the read performance. And people don't tend to understand that. They think about reading lots and lots of data, but not everybody knows that SQL Server has to commit the transaction to disk before it will then go on and give that transaction back to the end user as marking it as complete. So your write disks need to be a lot faster than your read disks. Now, if I was to have something like a Fusion IO card, or because Intel is sponsoring this, some really nice Intel SSD hardware, then I would not be looking at 20 milliseconds. If I had 20 milliseconds, that would be a massive problem for me. And so it is a case of obviously check with your workload, because then we'd want to be seeing things under 1 or 2 milliseconds typically. So again, it does go back to your environment in terms of what you're looking to see. The throughput side, that's a bit more difficult to kind of gauge. And typically when I'm looking at those kind of things, I'll be wanting to do moving big amounts of data. So ETL loads, backups and restores. That's when I'll really be testing the throughput of any kind of architectural system that we're looking at.
And of course, this is a little bit clouded by the fact that who knows what we've got that's actually our storage subsystem. We may be attached to a LUN on a SAN. We may have direct attached storage. Who knows, right?
Absolutely. In some cases, you might even be attached to a USB stick in the back of the cord somewhere.
Right, that's true.
You laugh, but I've seen people back up to those because they've run out of space. Yeah, it's absolutely crazy. So it is very, very difficult, and that's where the whole documentation piece comes in. You may or may not like your SAN admin, but it's worth having a beer fund to be able to speak to them and get the information that you need.
Absolutely. It's very, very important. All right. Well, we're about 15 minutes away from the end, so we're going to have to move a little bit quickly now. Another set of things that you want to capture as you go through this process, if you haven't ever done it before, is a couple at the top here. Access methods, for example, forwarded records per second and page splits per second. Those may be indicators of situational problems. Forwarded records only occur on heaps, for example. Page splits are both a good thing and a bad thing. So page splits happen on whenever you're doing normal inserts and a new page needs to be created for that, but it also happens when inserting into a existing page that's completely full, and then it has to split out two records. And so, two pages. And so that can be an indication of kind of the ongoing fragmentation of your clustered indexes and such. So it's important to keep an eye on that and related sorts of things. Batch requests per second tell us how busy your system is. Page reads and page writes per second, that tells us how much activity is going on with the buffer. And so again, keep an eye on these. Normally, you don't want any forwarded records happening. It's not always bad, particularly if the tables are extremely small that are being used, 64K or less, it's not a problem. But if they're big tables, that is a problem. Page splits, as I mentioned, it depends a little bit. And then with a few other things like connection pooling or MARS or things like that, got to be careful about those. All right, so let's move on. One other tip I want to throw out about PerfMon counters too is that there is a PerfMon counter that most people have not heard of, and it's called deprecated features. And so if you are actually upgrading a server or migrating it to a different kind of environment, make sure you capture this before the move happens. Remember, we mentioned that with baselines, how you do comparisons of before and after. This tells you the number of times that deprecated features are used in that baseline workload. And so this can help you determine if there's any potential rewriting or things like that that needs to happen for your SQL server. Now, how do I do this? If you haven't ever done this before, there are various videos that you can watch to use PerfMon to go through the process of capturing all this information. You will, however, want to use more than just PerfMon. As we mentioned, there are certain dynamic management objects, for example, DMOS weight stats. So to capture the weight statistics, you'll want to run queries against those over time. You can also use Profiler and extended events to capture quite a lot of information, very powerful stuff. And one other quick note that we wanted to throw out is that there is a query that you can issue against a DMV called sysdmos performance counters. And what this enables you to do is you can get all of your PerfMon counters related to SQL Server, not the Windows ones, but all of the SQL Server ones, and you can store those in a table if you wanted to. So with the exception of those IO counters, you can get through quite a lot just by running a query on a regular basis while you're doing the baseline and saving that for analysis after the baseline test is done. Now, what else should you capture? You want to get some information about the workload. You want to get information about plans from the cache. And then don't forget SQL agent. So we do see this happen a lot where people are very conscious, DBAs doing this are very conscious of what the end users are doing, but they are less conscious about what SQL agent is doing. So you want to make sure you get all of that information about what the agent is doing, whether it's kicking off anything in the midst of all the other activities that are happening generated by the end users. And weight statistics. Mentioned that a couple times, but just thought we'd mention it again. Okay, one other tip important to mention is that TempDB is extremely heavily taxed by any work that we do on SQL Server. Even if you have a system that is only read-only and is just doing select statements, well, as it turns out, anytime a hash join is used in a select statement, anytime an order by is used in a select statement, and lots of other situations, SQL Server will use TempDB to resolve those queries. So keep an eye on TempDB as well as the main user database that you are doing a baseline on. Okay, don't forget that. Now, when you run that test, also keep in mind that you've got to do an analysis at this point, right? And once your testing is complete, you want to consult with the various teams involved and figure out, and maybe just for you, but it might involve, say, the SAN team or the network team if you're measuring network throughput, for example. And you want to set the thresholds that you're going to alert on. Rich, do you have any other thoughts that you want to add to setting the thresholds up?
No, it just kind of, it's a nice recap. I can't say it now. Nice recap of recapitulation. That's the word I was searching for.
That's right.
So yeah, it's just a nice recap to bring everything together, really. So obviously we can give you all the kind of base guidelines that you need. That's no problem, but that might not be the right value for you. And so it is all about understanding that workload. You won't understand the workload unless you're capturing these key metrics to understand the deltas that your workload are going to have. Then it's all about having a ranged approach to say when things are above or below these and being alerted to those key indicators that you know are going to be true alerts rather than potentially causing you lots of false positives. Right. So a false positive would be something like, oh, my CPU, when it's above 80%, that's a problem. Well, in my maintenance window, it could be very, very normal for me to have CPU above 80%. because I'm doing lots of CPU intensive things like dbcc check db, hopefully, rebuilding my indexes or reorganizing my indexes, again, hopefully, because these are ongoing maintenance things that need to happen within SQL Server. And that high CPU is to be expected at that time, not something to be fearful of. And so we need to make sure that we're receiving the right alerts at the right time, or we will start to discard the results coming back to us. That will lead to complacency. That will lead to you updating your LinkedIn profile.
Indeed, it will. We call that noise. And so you want to be able to filter out all of the noise. Now, in case you haven't ever actually gone to the step of implementing those baselines for an alerting system, what you would then want to do at this point is you would actually want to go into the SQL agent alerts. And there you can configure performance baselines that are basically evaluating against a specific value that you have determined is normal in your by looking at and analyzing those PerfMon counters. So, for example, let's say you ran your baseline, you polled every 5 minutes against your database, collecting this information with PerfMon. You then load that into some SQL tables, and you say, oh, it looks like the average value for my CPU, let's say, is 40%. You might then create a SQL agent alert that says if it's ever, let's say, 50% greater than the average. So if it's ever 60, I want you to send me an email alert and let me know that CPU is unusually high. And so that's how you would implement that ongoing 24/7 monitoring that incorporates your findings. Now, that's one way to do it. It could be pretty difficult to implement that because you might have a dozen servers where you do baselines and each one needs different values. The good news is, and if you need help with this, I have scripts, Rich has scripts that kind of already have a lot of the most common error conditions to alert for using the SQL agent alert. And from there, it's not hard to make the leap to performance thresholds alerts inside of the SQL agent alerting system. So that's how you get that set up and running to let you know when problems are coming so that you can fix it before your end users ever pick up the phone and start complaining. Get to that proactive position.
Okay, guys, I apologize. I need to step in. We only have about a minute, and I think we might be a minute overdue.
Oh, okay.
So
I thought we had till the top of the hour.
Yeah, I would like to thank the audience for attending, and most certainly to thank Kevin and Richard for this, I would say, exquisite presentation.
Oh, so thank you so much.
Yeah, I think we will be disconnected pretty soon.
Okay.
Once again, I thank everyone, and I would like to invite everyone to stay tuned for the next session, the Real Self-Tuning Database with Gail Shaw.
Folks, if you have any additional questions, drop us an email, reach out to us on Twitter. We'll answer all your questions afterwards.